1. From concept to final design. Step-by-step project evolution. Architectural design is a process of reasoning, not an act of instant creativity. Every successful project evolves through clear stages that transform abstract ideas into buildable form. Understanding this sequence helps students design with intention rather than guesswork. The design process begins with the concept, which is not a shape but an idea that guides decision-making. A strong concept may respond to site conditions, cultural context, function, or a narrative intention. It acts as a filter through which all design choices are evaluated. After concept formation, the architect studies the site and program together. Site constraints such as climate, access, and surrounding context must align with functional requirements. At this stage, relationships between spaces are identified before any detailed form is developed. Massing and spatial testing follow, using simple volumes to explore scale, proportion, and orientation. These early studies help identify how the building occupies the site and how spaces relate vertically and horizontally. Complexity is avoided in favor of clarity. Design development refines the chosen massing into plans, sections, and elevations. Structural systems, circulation, and environmental strategies are integrated to ensure the design works in reality, not just in concept. The final design represents a resolved architectural narrative. When the process is logical and disciplined, the final building clearly communicates its idea from concept to detail. 2. Architectural diagrams explained. How to read and draw them. Architectural diagrams are thinking tools, not decoration. They simplify complex information to communicate ideas quickly and clearly. Good diagrams explain why a design decision was made, not just what the design looks like. There are several types of diagrams used throughout the design process. Concept diagrams express the main idea. Zoning diagrams show spatial organization, and circulation diagrams explain movement. Environmental, structural, and service diagrams further clarify performance and logic. Reading diagrams requires understanding hierarchy and emphasis. Colors, arrows, and line weights indicate relationships, direction, and importance. A good diagram focuses on a single idea rather than attempting to explain everything at once. Drawing effective diagrams requires restraint. Each diagram should communicate one clear message using minimal visual elements. Simplicity improves readability and strengthens design communication. Many students make the mistake of over-designing diagrams. Excessive colors, textures, and labels often hide the main idea instead of clarifying it. Diagrams should remain abstract and analytical. Strong diagrams allow a viewer to understand the design logic without verbal explanation. When diagrams are clear, the architecture speaks for itself. 3. Site analysis explained. Sun, wind, access, and context. Site analysis is the foundation of all architectural decisions. It allows designers to understand the forces acting on a site before introducing form. Ignoring site analysis leads to inefficient, uncomfortable, and poorly integrated buildings. Sun analysis examines the path of the sun throughout the day and across seasons. This information informs building orientation, window placement, and shading strategies. Proper solar control improves comfort and reduces energy consumption. Wind analysis identifies prevailing wind directions and speeds. Understanding airflow helps designers position openings for natural ventilation and protect against unwanted drafts or dust. This is especially important in warm climates. Access analysis considers pedestrian, vehicular, and service movement. Clear entry hierarchy ensures intuitive navigation and safety. Separation of public, private, and service access improves functionality. Context analysis studies surrounding buildings, topography, views, noise, and cultural patterns. The new building must respond to its environment rather than ignore it. Scale, height, and alignment play key roles. A well-executed site analysis transforms constraints into design opportunities. The site becomes an active contributor to the architectural concept. 4. Form development strategies. Massing studies that work. Form development begins with massing, which represents the overall volume and organization of a building. Early massing studies help test ideas quickly without committing to details. This stage is about proportion, orientation, and spatial relationships. One common strategy is subtraction, where volumes are carved to create courtyards, terraces, or light wells. Subtraction improves daylighting, ventilation, and spatial quality while reducing bulk. Addition is another strategy, where the building grows through modular or program-based volumes. This approach is useful for phased construction and flexible layouts. Each added volume should serve a functional purpose. Transformation strategies involve rotating, stepping, or splitting masses in response to site conditions or views. These manipulations help break monotony and improve environmental performance. Form should always respond to function and context, not personal style. Sculptural forms, without justification, often result in inefficient planning and construction challenges. Successful form development is iterative. Through testing and refinement, the architect arrives at a form that feels logical, balanced, and purposeful. 5. Space planning mistakes students make. Space planning is where many student projects fail despite strong concepts. Mistakes often arise from rushing into form without understanding spatial relationships. Good planning requires patience and critical thinking. One common mistake is the lack of spatial hierarchy. When all spaces are treated equally, important areas lose emphasis and circulation becomes confusing. Clear zoning improves usability and comfort. Poor circulation is another frequent issue. Long dead-end corridors, unnecessary level changes, and unclear movement paths disrupt user experience. Circulation should be direct, intuitive, and efficient. Ignoring human scale leads to uncomfortable spaces. Oversized rooms feel empty, while undersized spaces feel restrictive. Dimensions must respond to actual human use. Many students design from elevations or 3D views first, resulting in attractive forms with dysfunctional plans. Architecture must be planned from the inside out. Avoiding these mistakes requires constant testing, diagramming, and feedback. Strong space planning is the backbone of successful architecture. Architecture is not about talent alone. It is about method and discipline. By mastering the design process, diagrams, site analysis, form development, and space planning, students gain control over their designs. Process-driven architecture leads to clarity, confidence, and stronger outcomes.